For this project, a lightsaber was built using different machining processes such as milling, turning, and additive manufacturing, and also different materials such as PLA for the 3D printed parts and aluminum for the machined parts. The whole lightsaber assembly was divided into 5 parts. Each part was manufactured with Poka-yoke techniques to ensure a perfect assembly every time, regardless of the person who performs the assembly. Bases for each part, built with Poka-yoke techniques as well, were 3D printed to position the parts in place for the assembly. Then the Motoman robot was programmed to perform the whole assembly process. Once it finishes, the robot automatically returns to its home position.
The assembly station is this one, and all the bases for the pieces were placed in each position. This number 1, 2, 3, 4, and 5. We have different pins that can fit with only one position in this station.
Well, we have the complete lightsaber right here, but for our workstation, each piece goes into a specific station and only goes in a specific position. As you can see, if you try to put a piece where it doesn't belong, it simply doesn't work, and it has an original position. This one is here, this one is here, and as you can see, only in the right position it goes all the way through. And finally is this one. As you can see, it has a specific Poka-yoke for this entry, so it will go only just like this.
To make sure that all the pieces were positioned correctly, we used limit switches, and then we connected them to the controller of the robot. As you can see, all these green cables go to the input pins from pin 37 to pin 40, and then we connected all the grounds to this breadboard, which is connected to the ground here of the controller.
Then to see it in the controller here, we use the universal inputs here in out, the universal input. And as you can see here, we have named the switches as switch 38, 39, 40, and 41. That these names are also in the controller part. And to call it in the program, we use these numbers that are the input 3, 4, and 5. That if you see it here in the program, are here.
You need to wait until the input is on. So we are going to show you. We don't have any of the pieces, but when we position them, you will see how each of the inputs turns on. Once each of the parts is located properly in its base, the robot starts the assembly process. The first piece, which is already located in the assembly station, doesn't need to be moved. From there, the 4 remaining parts are located one over the other, ensuring all of them are positioned and oriented correctly. That is why all the project was performed using Poka-yoke techniques.
Number 1 goes at the base, and it uses turning and milling. The first part uses tools for facing, roughing, grooving, and finishing. The milling part uses 2 different setups. One is used to create the Poka-yoke that goes to the base, and the other to the Poka-yoke that goes to the second piece. We use 2 different assembles, so the tool reaches all parts of the design.
This is the piece number 2, and for this piece we use both milling and turning. For the turning part we use tools for facing, roughing, finishing, and cutout. For the milling part we use two different setups. The first setup was the one that we made a pokayoke that will be assembled with the first piece, and also the counter we did a little grooving. And the second setup of the milling part, it was the other pokayoke that will be assembled with the third piece. And all this setup was made so the tools will reach all parts of the manufacturing design.
Part 3 was 3D printed in PLA to save material when machining this part, and also due to the complexity of the details in the part, it was easier to do the process in 3D print. And well, we have here the part. This part contains two pokayokes that are here and here, connecting the part number 2 and the part number 4. Piece number 4, in this piece we use both turning and milling. The first part is useful for facing, roofing, finishing and cut-off. The milling part uses two different setups for each of the pokayokes, showing here and here. And also for the roofing part was used a neutral tool to do these sections that are shown here along over the piece. And well, this piece assembled with the third and fifth piece in the pokayoke section.
This is the last piece. It was manufactured using mostly turning, with tools for facing, roughing, grooving, finishing and cut-off. The milling part used only one setup, where the pokayoke was made to be assembled with the fourth piece.
So we have three main areas where we had problems of manufacturing this lightsaber. First was the metal pieces that had to be manufactured. For example, we didn't take into consideration some holding pieces for the next procedures, so that was problem number one. Second, when we started programming some pieces, we weren't considering the position that the cutter was going to end. So when visualizing the program and how it was manufacturing each piece, we realized that there wasn't enough space for the cutter to go all the way through. So we had to cut it manually for some pieces, and for the next ones, we had already this into consideration. Then the second problem was the 3D manufacturing pieces. It's only this one actually. But some of the pokayokes needed to be redone because of the tolerance that were put into the consideration of the 3D printing manufacturing, and finally the programming of the robot. This was incredibly difficult because there wasn't really a lot of information that we could find, so we spent many days investigating by our own, but finally the system came together.
This project was a very exciting, enriching, but also time-consuming project. Machining all these complex parts made us not only get more familiar with CAD, CAM, CNC machines and machining processes, but also with all the problems that might come out when parts are not designed for manufacturability. This project gave us an insight on how important tolerances definition are to ensure a correct assembly, and how important it is to think about the tools that will be used for machining and how the part will be fixed to the machine when designing the parts. In addition, we learned how to program and control the Motoman robot, always following the safety instructions for handling.